Hi guys, and welcome back. Today we are talking about the different forms of energy. So as we move into this unit, today it's going to be really important just to review what types of energy exist in our universe, and then you guys are going to explore some of those today. A lot of this will be a review because I know that we've talked about this probably in the 8th grade. And also we've talked about heat energy in this class so far. So if it's a review, that makes sense, but we still have to make sure we're all on the same page before we move forward with like calculations and stuff of that nature. So without further ado, let's go ahead and get started and talk about the different types of energy. So what is energy? Energy is the ability to do work on objects, and there are two forms of energy. We'll talk about these a little bit more in tomorrow's lesson, but these two forms are kinetic energy and potential energy. So kinetic energy is the energy a moving object has because of its motion. So objects in motion have kinetic energy. And then potential energy is stored energy due to an object's position, right? And like I said, we'll talk about that a little bit more tomorrow. So here are the different forms of energy that we're going to be going over really quickly. And again, I'm going to go over these specifically, so this is just a slide that kind of summarizes all of them. Now, before we talk about the different types, it is a good thing to note that energy can be transferred or converted from one form to another. So you see all these different forms of energy here at the top, so mechanical, thermal, chemical, light, electrical, nuclear, and sound. All of those can be converted from one form to another. So we're going to keep that in mind over the course of this unit. All right, so mechanical energy is energy associated with the motion of an object. And examples of this would include chewing. So if you think of like chewing food or chewing gum, the movement of your jaw, that would be mechanical energy. Sound is a mechanical energy. And also we have a little clip from Looney Tunes here with this frog dancing. He is in motion and he has mechanical energy. Thermal energy or heat is the total energy of the particles in a substance or a material. All objects give off thermal energy, and you as a human also give off thermal energy. Ice cream melting would be gaining thermal energy, so gaining that heat, gaining that thermal energy, which causes it to melt. And if you guys remember too from Unit 1, when we did matter, we had a lesson on conduction, convection, and radiation, and those are the different types of thermal energy and how it is transformed. Chemical or atomic energy is potential energy stored in chemical bonds. Examples of this would be like food, firecrackers, your stomach acid breaking down energy, and then also a battery. So the reason that these are chemical energies, so these have energy stored in the bond. So like for example with food, when we eat it, there is energy that we can extract from that food, right? So it does store that energy in its bonds. We can then through the process of digestion break down that energy and absorb it. And then of course there is a biological process that we should all remember from biology to do that. Light or radiant energy is energy contained in beams of light, and examples of this would be the sun, light bulbs, and other sources of light. So if you can think of a light source, that would be a type of light or radiant energy. Electrical energy is the moving electrical charges that produce electricity and energy. So things like this would be static shock. So if you're wearing like a fuzzy sweater and maybe fuzzy socks and you're walking across carpet and then you touch your hand to a doorknob, sometimes you feel that little spark. That's a static electricity shock. Lightning, of course, is electrical. Computers, TVs, radios, and also lights have electrical energy. Okay, so and you can see too some of these examples are different types of energy or multiple types. So like lights would be both electrical and radiant energy. Okay, so remember energy can be transformed, and then different types of energy can have multiple forms of these energies. These are just going to be some of those really good examples here. Sound energy is energy caused by an object's vibrations. These are just sound waves. So in our ears, we have those three little bones that pick up sound energy and convert it, or pick up sound waves and convert it to sound for us. That's the way that our ears work. It's a lot more complicated than that. But sound waves that are given off are then picked up by our ears, and that's how we convert it to energy or into sound, and we can hear it with our ears. And then nuclear power. So we have talked about nuclear power a little bit when we did our unit on our nuclear chemistry. So nuclear power is energy stored in the nucleus of an atom from fission or fusion. And if you guys remember from back when we were doing our lessons on chemistry, fission is when an atom breaks apart, and fission is man-made. So this would be like in nuclear power plants and atomic bombs where we figured out how to split atoms and release that energy. Fusion is natural. It occurs in sun and stars, and the fusion of those lightweight elements to become heavier elements is what kicks off that radiant energy. And then of course we see it in the form of light, and we feel it in the form of heat. Okay, and nuclear power plants we use to power to give off electricity. Okay, so the way a nuclear power plant works is that typically it's uranium that's used, that's the source, and it's put into a nuclear reactor. The nucleus of the uranium element is broken apart, and then that gives off heat, and that heat is used to create steam, which then turns a turbine, which then generates a flow of electrons, which then generates electricity. Okay, so it's not the actual breaking apart of the nucleus itself that's giving us the electricity. We're using the heat that's given off in order to turn a turbine to generate that flow of electrons. Okay. And the last thing we're going to talk about today is just temperature, which is a measurement of heat. So temperature is the measurement of the average kinetic energy of the particles in a sample of matter. Remember, kinetic energy is in anything that has motion. And thermal energy is the total energy of the particles in a material. So kinetic energy is the movement of the particles. If an object has faster moving particles, so more kinetic energy, it will be warmer. Okay, so the more kinetic energy, the warmer it will be. Potential energy are those forces within or between particles due to position. So the sum of the kinetic and potential energy of all the particles in an object is the thermal energy of the object. It's going to depend on temperature, mass, and type of substance. And like I said, we're going to talk a little bit more about potential and kinetic energy in tomorrow's lesson. Today, we're just really focused on the different types of energy and exploring those a little bit more. Okay. All right. So those are the different types, their definitions, and then just examples of each of them. You're going to explore a couple a little bit more in your assignment for the day, but if you have any questions, let me know.